Our focus on 9.2 has to do with multiplying and factoring polynomials. And we're just talking about factoring just greatest common factor out. So that's going to be our focus in this section. Now, in order to solve some of these problems, I may actually use some techniques we used in elementary school in order to kind of find the easiest way to solve these. So let's take a look at the first couple. First of all, in a multiplying problem, multiplying is going to go with the directions for both example 1 and example 2. So if we take a look at this first one, it's 4b times 5b squared plus b plus 6. First of all, we do assume that there's a 1 in here, even though it's not written. And this is a big form of distributive property. We have to be able to distribute this 4b to all of these values that are in the parentheses. Now, kind of an easy way to do that would be to use a technique we use in traditional multiplication. That if I take something like this, if I have 179 times 62, most of the time when you see a problem like that, you're going to have it lined up with the 179 on top and the 62 below and a multiplication sign in the line. Now in this one, typically the 62 goes second because it has the least amount of digits, and the 179 goes on top because it has more. Now if they happen to be equal, we can put one on top and one on the bottom and deal with it. The nice thing for us in the problem that we're going to look at, kind of the longer version, would be this 5b squared plus 1b plus 6. That has 3 terms. It's a trinomial, so it's longer. And 4b happens to be just 1 term. So actually when I set up this problem, I'm going to do 5b squared plus 1b plus 6. And then I'm going to take this 4b and I'm going to write it just below it. I'm going to go way out here and make my multiplication sign and draw my line. I'm putting this out there because eventually we are going to be having the letter x in these. So we want to make sure that we don't get this x confused with an x that's actually a variable. But I also want there to be no doubt that this is a multiplication problem. So that's done just to kind of make things easier. And really our job then is take this 4b and to multiply it by every single thing that's there. So 4b times 6 is going to be positive 24b. Now these b's, we do assume have the exponent of 1. So when I go to do 4b times 1b, that's going to actually end up being 4b squared. Because remember, the rule is with exponents that if the bases are alike and you're multiplying, you add the exponents. So there's 1b here and 1b here, which would give you 2 in your answer. Now if I look at these two, 4b times 5b squared is going to be 20b cubed. Again, this cubed to the 3rd power because there's 2 there and 1 there. Now, if I go to this problem, I'm going to do the same kind of thing. I'm going to take this, and that's going to be the value that goes on top. So 3h squared minus 8h minus 1. Negative 7h is going to go below. Do my multiplication way out here and draw my line. Now in this problem, negative 7h is going to get multiplied by every single thing that's here. So negative 7h times negative 1 is positive 7h. Negative 7h times negative 8h is positive 56h squared. Because remember, there's 1h here and 1h here, which gives you 2 there. And then negative 7h times 3h squared is going to be negative 21h cubed. Now, a big part of this is also, I don't know if you happen to notice, but these ones right here, this longer version, is in standard form. So it goes from h to h squared to just your number. The same thing over here. This goes from b squared to b to your number. So if you have this part in standard form, that means that when you're done, your answer will also be in standard form, which is kind of helpful to consider. Okay, now let's go on to dealing with greatest common factor. So let me just cover up part of this for a minute. Okay, and let's just deal with this part. So greatest common factor, they're going to talk about a lot, and they're going to start using this GCF. In fact, you're very, very unlikely to actually see them write greatest common factor out after they mention it once, because they'll assume that you know what it means. And really, they want to find the biggest number that will go into everything and any variables that they happen to share. So let's take a look at some of these and realize these are problems that won't require a lot of work to solve either. So on these problems right here, I have 15w plus 21. So if I just look at the numbers, 15 and 21 both have a 3 that will go into both of them. So that has to be part of our greatest common factor. Now 3 happens to be the largest number that will go into them, so that's something to think about. There's a w here, but no w here. So there's not anything else that they share in common. So that means that the greatest common factor will just be 3. Now in an example like B, let me write my greatest common factor, my little abbreviation here. 6 and 8 will both have a 2 in common. Largest number that goes into both. Then if I have a squared and a, remember a squared is really a times a, isn't it? So if that's true, that means they both have at least one a in common. This one has 2, but since this one only has 1, the most they have in common is a. So greatest common factor can also include variables as well as numbers. So our job in this section is to take what we just learned about greatest common factor and apply it in a factoring situation. So take a look at these next couple examples. We want to use the greatest common factor to actually factor both of these. So really our first job on these is to actually identify what the greatest common factor is. And I'm just going to do that up here. So in this one, if I look at all of these, 3 would go into all these numbers. It would be the largest one. And they all have at least one x in common. So that's x. So that's our greatest common factor. Now I want you to watch what I'm going to do. I'm actually going to go underneath this problem and skip a line, and then I'm going to go down and I'm going to write 3x and write parentheses. Really what we're trying to do, if I just back up for a step, is we're going to get an answer like we're going to start with this part down here, and they're going to actually want us to come up with the answer up here. So we have to be able to find this number to kind of pull out of every single number. So the 3x happens to be the number that they all have in common. Now, whatever your greatest common factor is, I'm going to divide every single thing by that number. Which means that if you were to look at this, I can see that these 3's here and these x's here are going to cancel. But now we've got some stuff kind of in the middle to deal with. Now, in this one, if I have 3 x's here and I'm going to divide away one of them, that would leave me with 2. Remember the rule for dividing with exponents is if the bases match, then you have to go through and subtract the exponents. So that's what we did here. Now I'm going to bring my minus down. 12 divided by 3 is 4. X squared, I'm going to take away the 1 that's on the bottom, will leave me 1. Bring my plus sign down. 15 divided by 3 is going to be 5. Now let's say I get an answer and I'm not really sure if that's right. I should be able to take this and multiply it back out, and I should be able to get 3x cubed minus 12x squared plus 15x. I should be able to do that. So keep that in mind. Okay? Okay, now in this next one, if I look at all these numbers, 6 is the biggest one they have in common. Now I could see how somebody could look at this and see, oh, 2 or 3 or 6 could go into those. But you want to choose the highest one, so choose 6. Also, these all happen to have an m in common. Now I'm going to do the same thing I did before. I'm going to skip a space, and I'm going to down here and write my greatest common factor out here, and then my parentheses. And now what I'm going to do is I'm actually going to divide each of these by 6m. So if I divide those out, I can actually see in this one that these cancel and these cancel. So in this one, m cubed, and this is m, I'm going to add my exponent of 1 because sometimes that helps you guys here. So there's 3 here. I'm going to take away the 1 on the bottom, which would leave me 2. I'm going to bring this subtraction down. 12 divided by 6 is 2. There's 2 m's. I'm going to take away 1, and I'll have 1 left. Bring this subtraction down. And then 24 divided by 6 is 4. Now remember, in this kind of a problem, I could multiply this back out, and I should get back from it my original statement, that 6m cubed minus 12m squared minus 24m. Okay, let's try one more. This is a simplifying problem, and that's generally the directions you're going to see when they really want you to go through and kind of distribute this. So let's set this up like the one I did earlier. So 3g cubed plus 6g minus 5 and negative 2g squared here. Draw my line. And then I'm going to go through and start doing my multiplication of the negative 2g squared on every single thing. Now, I am going to add my 1 there just because I think that helps sometimes when we're multiplying, just to remember it. So negative 2g squared times negative 5 is positive 10, and that g squared just goes in the end. There was nothing to combine with the g part. Then negative 2g squared times 6g to the first is going to be negative 12 g to the third. Now last one, negative 2g squared times 3g to the third is going to be negative 6 g to the fifth. Now please make sure that when you're combining them that you do check to begin with if this is in standard form. That will ensure that your answer down here is going to be in standard form. Okay, and then also be sure that you're checking your negatives to know which numbers are still going to have 1 and which ones aren't.